Hi friends, in this video, very important point, hunting. So can you tell me what is the hunting? What is hunting? Hunting nothing but sudden change in speed. Is okay? What is that? This is a very sudden change. Sudden change in speed is called hunting or jerkings or joltings. Jerkings and joltings is also called hunting or simply vibrations of rotor is also called hunting. Like this is called hunting. Nothing but dance of synchronous machine is called hunting. The music of transformer is called humming. The dance of synchronous machine is called hunting. Sir, what are the reasons for hunting? What are the main reasons for this process? Can you tell me? Yeah, the reasons are first one, sudden change in load. If load changes suddenly, for example, if load decreases, speed increases. If load increases, speed decreases. This is the main reason for hunting. And next one, sudden change in frequency, supply frequency. If frequency increases, synchronous speed increases, then rotor speed increases. If frequency decreases, synchronous speed decreases, then it goes to hunting. This is also main reason. And next reason, sudden change in excitation. These three are the main reasons for hunting in our synchronous machine. Are you okay? Getting or not? Right. So, how we can eliminate this hunting process? Can you tell me how we can eliminate this hunting process? First one, remedies. Remedies. What are the remedies to avoid the hunting? First one, by choosing better synchronizing power coefficient. I said you already, when disturbances occurs in the machine, synchronizing power coefficient comes into action to avoid the disturbance, to make it in synchronization, to make it in normal condition. So by choosing the better PSY, we can avoid the hunting. This is the first thing, very important. And the second thing, by using flywheel on rotor. This is also important thing. Here the word flywheel, by using this small part also we can avoid the hunting. Sir, what is flywheel? Can you tell me? Can you anyone see this one? What is flywheel, sir? Flywheel is a mechanical device which mounted on same shaft. What is that? Mounted on same shaft, and it stores, what is that? It stores kinetic energy of rotor. Very important. It is the work of the flywheel is it stores kinetic energy of rotor. Can you tell me how much that kinetic energy? That kinetic energy is equals to of mv square, that is in physics, but in synchronous machine of mv square. Here I is the moment of inertia. moment of inertia 1, and omega is the angular velocity. What is that? Angular velocity square we have to take here. So the kinetic energy is equals to half I omega square, which stores the kinetic energy. This is the work of our flywheel. Sir, of course, it stores the kinetic energy, then how it will avoid the hunting? For example, suddenly load increases, then what happened? Actually speed decreases, but it avoids the process, because when load increases, it will give the energy or power to the load by the discharging of this energy. Nothing but when load increases, it releases the stored energy. That's why there is no changes in speed. For example, suddenly the load decreases here. When the load decreases, then actually the speed should be high, the speed should increase, but it avoids that process, because when the load decreases, the extra power stored in flywheel, it stores that extra power. That's why the flywheel is also called load equalizer, because it equalizes the load. That's why it is called load equalizer. So finally what it will do, the fly will do what it will do, it avoids what happened, it avoids sudden changes in speeds. This is the main thing of the flywheel. That's why we are using to avoid the hunting. Sudden change in speed is the hunting. What fly will do? The fly will do, it avoids the sudden changes in speed. That's why the flywheel, by using flywheel, we can avoid the hunting. So tell me, what is flywheel? It is a mechanical device which mounted on the same shaft. It stores the kinetic energy of I omega square. It is also called load equalizer. It avoids sudden changes in speeds. So here, first one, by choosing the better synchronizing power coefficient, and next one by using flywheel on the rotor, and third, very important, generally we are using by damper winding. What is that? By using a winding which is called a damper winding, we can avoid the hunting. This third one is our topic actually. Damper winding is our topic. So let's see about damper winding. Before that, what is the overview of hunting? Hunting nothing but sudden changes in speed, or jerkings and joltings, or vibrations in the rotor. The main reasons are the change in load is 100% wrong. The change in frequency 200% wrong. Sudden change in load is correct. Sudden change in frequency correct. Sudden change in excitation is correct. Remedies, by using better PSY, by using flywheel, and by using damper winding. Let's go for damper winding. So see how we can avoid hunting by using damper winding. Next heading, damper winding of synchronous machine. See, next one. This is very important point here. For example, I am taking a synchronous machine. This is my salient pole synchronous machine. Of course, we are taking field winding here, and this is the armature, of course. Now, where we have to take this damper winding? Generally, the damper winding placed under pole shoes. This is a short-circuited winding. This is a short circuited winding because here see this is a short circuiting. So damper winding placed under pole shoes. Where we are placing here? See clearly. Damper winding made up of, can you tell me? Yeah, very good. High resistive material. What is that? Like a copper alloy. We are using copper alloy, brass, branch, etc. High resistive material. This is placed under pole shoes. In generally, in alternator, damper winding is used to eliminate hunting. That's it. Only one thing, that eliminate hunting. What I am saying here, they will ask you question. In alternator, why we are using damper winding? In alternator, damper winding used to eliminate hunting, but in synchronous motor, it will do another work. I will give you there. But in alternator, it will do only one work. That is, damper winding eliminates the hunting. Sir, how it will eliminates the hunting? Generally, hunting nothing but NR not is equals to NS. This is nothing but hunting. NR not equals to NS बोले तो क्या समझे? NR not equals to NS, nothing but NR may be greater than NS or NR may be less than NS. For example, case 1 NR greater than NS, case 2 NR less than NS. When there is a change in the speeds, then the damper winding produces damping EMF because of induction principle. Here, due to induction principle, this is rotating at, for example, 1450 RPM. The flux is rotating at 1500 RPM. Induction machine principle. Then EMF induces in this rotor. That EMF is called damping EMF. When EMF produces, damping currents will flow in the damper winding because it is a short circuited. When damping current flows, it produces the damping flux. Damping flux produces when NR not equals to NS, be careful. Then there is a difference. When difference is there, damping flux came and we have a stator flux, and the interaction of damping flux and stator flux results is the damping torque. Results is the damping torque, which is very, very important thing. This damping torque do what? Eliminates the hunting. This is the process actually going on. The damper winding produces the damping torque, which eliminates the hunting. So tell me, is the damper winding producing torque is called damping torque steady state in nature or transient in nature? When NR is not equals to NS, then TD will comes into action and bring the NR is equals to NS and it will disappear. That's why when it is disappear, when NR is equal to NS. When it comes into action, when NR not equals to NS. That's why this is also, what is that? Transient in nature. Be careful. Transient in nature only, not steady state. This is right. Next one. For example, NR greater than NS. When NR greater than NS, ED will produce because there is a difference, and it produces the damping current, and it produces the damping flux, and due to interaction of stator flux, it produces the damping torque. Can you tell me what this damping torque will do? Is this damping torque increase the rotor speed or decrease the rotor speed? We have to make it equal. So to get the equal, here this damping torque do what? It reduce the rotor speed. Reduce the rotor speed up to equals to ns. This damping torque reduce the rotor speed up to equals to ns, then hunting eliminated. As usually, when nr less than ns, ed produces, which produces the damping flux, and automatically damping torque comes into action. What it will do? This damping torque. This damping torque, it increase the rotor speed up to synchronous speed. Yes or no? It increase the rotor speed up to synchronous speed. Then hunting eliminated and this TD disappears. Is it okay? Yes or no? Now they will ask you question. For example, my 6-pole 50 Hz synchronous machine. What is that? A 6-pole 50 Hz synchronous machine. Nothing but what is the synchronous speed? Very good, 1000 RPM. My 6-pole 50 Hz synchronous machine rotating at 1100 RPM. Then the damping torque is called. Then the torque developed by the damper winding is option A, synchronous generator torque, synchronous motor torque, induction generator torque, induction motor torque. Now tell me the answer. First listen the question carefully. A 6-pole 50 Hz synchronous machine operating at 1100 RPM. Then the torque developed by the damper winding is option A, synchronous generator torque, synchronous motor torque, induction generator torque, induction motor torque. Tell me. Nothing but which condition? Case 1 or case 2? Here 1100. But actually the synchronous speed is 1000. So the first condition, NR is greater than NS. Then damping torque produces. This damping torque is called, this TD is called induction generator torque. Very good answer. What is that? Induction generator torque. Why, sir? In which NR is greater than NS? Yeah, in induction generator, NR is greater than NS. That's why this damping torque is called induction generator torque only. Very good. Next question. For example, 6-pole 50 Hz synchronous machine operating at 900 RPM. Then the torque developed by the damper winding is. Tell me the answer fast. Very good. The second case. Here damping torque produces. This damping torque is called induction motor torque. Because only in induction motor the NR is less than NS. Very good answer. Very good answer. Now the final question. A 6-pole 50 Hz synchronous motor or synchronous generator operating at 1000 RPM, rotating at 1000 RPM. Then the torque developed by the damper winding is. That is case 3. What is that? Case 3. Case 3, NR is equals to NS. Now tell me, what is the damping torque? Can you anyone? Come on. Yeah, very good, very good. What is that? If NR is equals to NS, ED is 0. Because what is ED? ED is directly proportional to NS minus NR. When the relative motion is 0, ED is 0, then the flux is 0. Nothing but the torque developed by the damper winding is also 0. When the synchronous machine is rotating at synchronous speed, the torque developed by the synchronous machine is 0. Sorry, the torque developed by the damper winding is 0. Sir, when NR is equals to NS, then what is the use of damper winding? If Nr not equals to Ns, it develops the damping torque. If Nr greater than Ns, induction generator torque will develop. If Nr less than Ns, induction motor torque will develop. It will adjust the rotor speed equals to synchronous speed. Then hunting eliminated. Very good work. Good job. If Nr is equals to Ns, then what it will do? What the damper winding will do? It will do sleep. If Nr is equals to Ns, what is the work of damper winding? Nothing the work, just it will take rest on bed, on rotor, in pole shoes. It will take rest, that's it. So when the synchronous machine rotating at synchronous speed, the torque developed by the damper winding is 0. This is simply about the damper winding. Yeah, actually the concept is completed. What damper winding will do and how it will do and what is the torque. But now my question is, the hunting is more pronounced in salient pole or cylindrical pole? Tell me. Of course in both. You are saying that only in salient pole. Why? I draw here only salient pole machine. I am explaining about only salient pole machine. That's why you thinking that this is more pronounced only in, or this is pronounced only in salient pole machine. Why not in cylindrical machine? Even in cylindrical machine also hunting is there. Is it not possible to sudden change in load in cylindrical machine? Is it not possible to sudden change in excitation? Is it not possible to sudden change in frequency? Yeah, it is possible. Then hunting also possible in cylindrical machine. Okay. In salient pole machine, damper winding placed under pole shoes, but in cylindrical machine, where is my pole shoe? Where I have to make it? Oh, good doubt. So tell me, how we can eliminate the hunting in cylindrical machine? Sir, by choosing the better PSY, okay. Next. Sir, by using the flywheel, okay. Next. Is the damper winding is preferable or not? Tell me that thing. Is the damper winding required or not? Tell me that point. Required or not? Yeah. Very good. What is the answer? The rotor itself acts as a damper winding because the rotor is like this. Yes or no? The rotor is like this now. So the rotor itself acts as a damper winding in cylindrical rotor machine. That's why no need of damper winding in cylindrical machine. The rotor ultimately avoids the hunting. What the damper winding will do, the same work will done by the cylindrical rotor itself. Yeah, understood? Right. So this is about hunting and damper winding of alternator. I am not discussed up to now about synchronous motor, just I am discussing about alternators. Right? Thank you.